As example 3, given the function y equals x cubed, so we're starting off for where we left off on Friday. List the parameters of the transformed polynomial function. If you only want to list like horizontal stretch by a factor of a third and you stop, I'm not giving you full marks. Because you maybe don't even know what axis is about, and you're just banking on me just marking it correct, and you're going to not put the axis because you're scared you're going to put the wrong one. That's what I think when you don't write it. Okay? So if you just write HS3, I'm not giving you nothing. First off, it's wrong because it's a third. And second off, you need to put other stuff. Okay? So we have a vertical stretch. What? By a factor of a half because it doesn't flip. About the x-axis. I'm already nice by letting you do VS. Write the rest. Okay? We have a horizontal stretch, and this is a nice one because the 3 is already pulled out. Remember, if the 3 isn't taken out in front as a GCF, then what happens? It's going to affect your what if you don't take the 3 out? It's going to affect your horizontal translation, right? So this 3 needs to be in front and outside of the brackets, but still inside the cubed, or else your horizontal translation is going to be wrong. You have to remember to take that out of there. Okay? So we have a horizontal stretch by a factor of 1/3 because it always flips about the Do we have any reflections? No, we have none because there's no negative in front of the half and no negative in front of the 3. So we have no reflections. We have a vertical translation 5 what? Down. So if you write vertical translation 5 or you write 5 down without vertical translation, I'm not giving you the marks. Okay? You need to write properly. I even let you do VT. Horizontal translation 4 what? Okay. So our basic x cubed is being moved. How do we move it? We're moving a graph. What do we do? Mapping. X, y is going to become what? You do what you say. So we say we have a horizontal stretch by a third. Horizontal stretches and reflections, we do what to the x? What operation? Multiply. So we're going to get 1/3 x, 4 to the left, minus 4, comma, 1/2 y, minus 5. So our original graph is at 0, 0, 1, 1, negative 1, negative 1. Why is that? Well, our original graph is y equals x cubed. If I plug a 0 in for x, I'm going to get y equals 0 cubed, which is 0, 0, right? If I plug in a 1, I'm going to get y equals 1 cubed, which is 1, 1. If I plug in a negative 1, I'm going to get negative 1 cubed, which is negative 1. What if I plug in a 2? Y equals 2 cubed, so y equals 8. So my next point is at 2 and 8. 1, 2, 3, 4, 5, 6, 7, 8. And my other one's going to be at negative 2 and negative 8. So that's the y equals x cubed graph. And I am going to label it. Because you can't assume that Mrs. Lepp knows what you're doing or what your little head's thinking. Okay? We don't want to assume that I know what you're thinking. Because first off, I don't. Second off, it's scary to always know what you're thinking. Snapchat knows what you're thinking, but other people, I don't know. Why is this thing buzzing? Pardon? Me? Okay, so we take our points and we plug them in. 0, 0. We get 1/3 times 0 minus 4. And then a half times 0 minus 5. So we get negative 4 and negative 5 as our new point. So 0, 0 becomes negative 4, 5. Then what about negative 1, negative 1? 1/3 times negative 1 minus 4 1/2 times -1 minus 5. -1/3 minus 4 is -13/3, which is, well, this would be -12/3. So it'll be -13/3. And this will be -11/2. 13/3 is 4.333333. And -11/2 is -5.5. So it's like here. 1 and 1. Get 1/3 times 1 minus 4. 1/2 times 1 minus 5. So this one you'll get 11/3 and -11/3, sorry, and -4.5. No. 1/3 minus 12/3 is -11/3. This one was 13/3. This one is not 13/3. It's a positive one. Okay. No, you're not. Who says that? No one. Oh my gosh. 9.66. I disagree with your statement just because it was not good. -4.5. Whoa. -3. So your graph is doing something like that, right? The whole thing moved. What's the domain and range of the transformed function? You have arms going in opposite directions. Let's think about x's. So do I have an x all the way along here? And then along here, and they keep going on forever? So what x's do I have? If you can basically do disco moves, you have x to infinity and you have y to infinity. So if you can disco move your equation, it's xer, yer. So the domain that's a round bracket. -infinity to infinity. And then the range is yer. So why did my domain and range not change? If you move an xer, yer graph, is it going to change it? What's the only thing that's going to change your domain and range? Right? Or possibly an inverse. Is an inverse going to even change this graph? It'll change the graph, but will it change the domain and range? Because your domain becomes your, and your range becomes your, and they're both xer, right? The graph will change. It'll be a sideways graph instead of this way, but still xer, yer. Okay. Bill's preparing to make an ice sculpture. He's a block of ice that is 3 feet wide, 4 feet high, and 5 feet long. I know you're jealous of Bill right now, but Bill wants to reduce the size of the block of ice by removing the same amount from all of the dimensions. It's quite a conundrum. He can't get it to fit through his door of his tiny house. No, tiny house with tiny ice, all problems. He wants to reduce the volume of the ice to 24 feet cubed. So he wants to remove the same amount. So if they want to remove the same amount or add the same amount, what can you use for that amount? Can't use a number because that's what we're trying to find out, right? What could we use though? You could use x. So the width now is going to be 3 minus x because we're reducing it, right? Feet. And the height is going to be 4 minus x feet. And the length is going to be 5 minus x feet. So he wants to reduce the volume of the ice to be 24 feet cubed. So what kind of polynomial could I set up now? Because that's the reduced volume, correct? Is it not? So what could I do? What's volume equal to? Length times width times height. What do we have there? Length times width times height. Set it equal to 24. So we have 24, which is the volume, equals the width times the height times the length. Now, in order to solve linear, we could just get x by itself. That was a great thing about grade 10. You didn't even know it. It was so awesome. Okay? Then we got to grade 11 and we solved quadratics. What did we have to do in order to solve a quadratic? No, get everything to one side and set it equal to. Anything over a linear equation, you have to get it equal to 0 to solve for x. Okay? Always. So a quadratic, you have to get it equal to 0 to solve for x. Cubic, which is what this is going to be. Why do I know this is going to be cubic? There's 3 x's and it's going to be x times x times x. It's actually going to be a negative leading coefficient of x, right? Because negative x times negative x times negative x, which is negative x cubed. Okay? So we have a cubic here. We're going to have to expand it. And we're going to have to get it equal to 0. So I'm going to leave the 24 over here for the time being so we can work together here. So we're going to expand this. We're going to FOIL this first. 3 times 4, sorry, is 12. 3 times negative x is negative 3x. Negative x times 4 is negative 4x. Negative x times negative x is positive x squared. And then that's all multiplied by 5 minus x, which you did this distribution in grade 10. So now we're going to go 24 equals 12 times 5. What's that? Yep. And then 12 times negative x. Negative 3 times 5. X. And then negative 3x times negative x. Don't know where I was going with that. Negative 4x times 5. Negative 4x times x. And then x times squared times 5. Positive 5x squared. X squared times negative x. Negative x cubed. So I'm going to bring this up here. Move the 24 over because you have to get it equal to 0 if you're going to solve a polynomial. The only one you can get away with is linear, right? Quadratics, cubics, quartics, quintics, so degree 2, 3, 4, 5, anything larger, you have to get it equal to 0 and then factor if it's degree 2, or anything higher, you have to do synthetic division, right? So we have 24 plus 60 minus 12x minus 15x. Yep. Negative 20x. Yep. Plus 3x squared plus 4x squared plus 5x squared minus x cubed. 8, 12. Minus 35 minus 47 plus 36. Okay. Is a negative x cubed better or a positive x cubed if you're trying to solve something? A positive. Why? What do I drop down in synthetic division? The coefficient of that x cubed, correct? If it's a positive one, I can just do product sum, brackets, brackets, golden when I get to that x squared. If it's a negative one, I have to do decomp. Okay? The great thing is you can't get rid of numbers in front, so if you have a 2 or a 4, whatever, you're going to have to do decomp no matter what. But if you have a positive one or a negative one, you can change them. Why? Because you have an equation. You have 0 equals an equation, correct? So yes, we moved everything to this side, but could we not move it to the 0 side? And then what would it do to all those terms? switch their signs. And then I would have a positive x cubed, and I wouldn't have to do decom. So I'm going to move these all to this side and get 0 on this side. So I'm going to get x cubed minus 12x squared plus 47x minus 36 equals 0. What works for synthetic? You're up for your calculators. I could take away your calculators. You guys could try plus or minus 1, 2, 3, 4, 9, 12, 6, 18, and 36. Did a little out of order, but nonetheless, same factors. Pardon? Oh, it would have worked out nicely if you had started 1. All right, x equals 1. And then we have, make sure we can count down, which we can. And we have 1, negative 12, 47, negative 36. Drops 1. 1 times 1 is 1. Negative 11. Negative 11. Is this going to work out? Yep. Okay, so we have x squared minus 11x plus 36. Did anything factor to give you 36, or multiply to give you 36 and add to give you negative 11? Nothing. Okay, so we'll try quadratic formula. Minus a minus 11 plus or minus the square root, because this is your a equals 1, your b equals negative 11, your c equals 36. Negative 11 squared minus 4 times a times c, all over 2 times 1. X equals 11 plus or minus. What's 121 minus 36 times 4? Ooh, this is going to be 121 minus 144. What's 121 minus 144? What happens when we have a negative under our square root symbol? No, you have no solutions. Okay, so what's our only solution? X equals 1. How much should he remove from each dimension? 1 foot.
Bill couldn't figure that out himself?
No, Bill needed his math. No, 1 foot. Oh my. Here. It's the only solution there is. Yeah.
Wait, so could we have just figured that out based on seeing the chart and seeing there's only one solution?
Well, there could be decimals. I would love to see how many of you would guess and check this, or you would do it this way. Yeah. All right. So A, determine the equation with least degree for each of the polynomial functions. This is the last piece. So we have a quadratic function. Quadratic function means what? Degree what? Thank you. Not 1/4. Okay. So quadratic is degree 4. So at maximum, how many x-intercepts are we going to have? 4. You always have maximum the degree, right? Okay. We have zeros. We have zeros of 2, multiplicity 3. What does that mean? How many of them do I have? 3. I'm going to do this one down here and then b beside it. So let's keep this in mind. We have y equals, leave a space here. Trust me, leave a little tiny space. And then our 0 is x equals 2. If I work that back, what is it? So I'm going to put an x minus 2 here as my factor. But how many of them are there? 3. So we put a cubed. And negative 5. So our other one is negative 5. When we work it back, what do we get? Now, this is something I want you to note. What if they said I have a 0? I was going to draw a Z. I don't even know how to, I don't even know where I was going. 0? No, it's a straight up and down line. It's just not happening. A 0 at a half. I think I was maybe doing the half. I don't really know what my brain was doing. So say we had a 0 at a half. So that would mean we have x equals a half. Please do not tell me the factor is x minus a half. That will not be there. Okay? Work it back. What will we have to do? Multiply by 2. So we have 2x equals 1, and then what would we do? So if your factor was this, you would move the 1 over, divide by 2, and get a half, right? So everyone does that, right? They'll go from 2x minus 1 and give me a half, and then I'll give you x equals a half, and you'll tell me x minus a half. It's not going to be there. Like x minus a half isn't wrong. It's just not going to be there. Okay? And they'll say integral factors. Integral factors means integer factors. Is half an integer? No, integers are positive and negative numbers that do not have decimals. A fraction is a decimal. Okay? So that's why they'll say integral factors. So they can make you do it. Or they'll say x minus a cubed x plus b, and then a and b are an element of the integers, like an I. They'll make it so that they have to be integers. Okay? So we have this. We have x plus 5. Okay? Everyone's really good at getting at this. They're very good to get to this spot. Okay? Then they forget an a in front. We need to find out what our leading coefficient is. Because remember when I told you when it was in factored form, and you had a 3 in front, let's say, you had a 3 in front, in factored form, does it change your x-intercepts at 3 in front? If you have 3, y equals 3, x plus 2, x minus 1. My x-intercepts are negative 2 and 1. Did that 3 change it at all? No. But that 3 does affect your y-intercept, because you're going to take 3 times 2 times negative 1, and you tell me my y-intercept's at negative 6, correct? So if your coefficient in front changes and it isn't 1, it will affect your y-intercepts, but it won't affect your x-intercepts, correct? So everyone will still, they'll give me this as the equation on a written response, and you're going to be right if you luck out and the a value is 1. But if the a value isn't 1, you're going to get it wrong. Because that a value can change drastically depending on what my y-intercept is or how much I've stretched it, right? But does vertically stretching affect my x-intercepts? No, because my x-intercepts y equals 0. And when you multiply 0 by any number, it stays 0. So that vertical stretch in front doesn't affect the numbers. Okay. So how do we find that a? Well, they have to give us something else. So they gave us a y-intercept, which means x is 0 and y is 30. They might, instead of saying y-intercept, they might say constant of 30. Why can they say that? Because your constant at the end is your y-intercept, right? Okay, so we have xy. Now we solve for a. So the first step is setting it up, then solving for a. You have to remember to solve for a. Star, 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 star. Everyone forgets to solve for a. Okay? What multiple choice answer is going to be there? When a is 1. For sure. So if you forget to solve for a, you got a backup wrong answer to pick, which stinks, but it's true. So let's solve for a. So we have 30 equals a, and then we have 0 minus 2 cubed, and then 0 plus 5. Now think about this. Bracket, bracket, beside an a. What are all those numbers doing to the a? What operation? You're multiplying. So some people will try and add and subtract whatever's beside it. No, it's multiplied by the a. You're going to divide it over once you figure it out. Okay? So you have 30 equals a times negative 8 times 5. 30 equals negative 40a. Divide by negative 40. A equals negative 3/4. Then people box this and they're like, I'm done. No, I asked you to determine an equation. You just found an a value and boxed it. That's fantastic. I like it. It is not at all what I asked for. It's part of what I asked for, but I asked for an equation. So that's great, you boxed it. You can now find it and insert it in for A. So y equals negative 3/4 x minus 2 cubed x plus 5. And now we actually have the answer. Now B. B has a quintic function. So degree what? 5. With zeros at -1 multiplicity 2. So we know we have y equals A. We always just put the A in right away because we have to find it. X what? If you have a 0 at -1, what's my factor? X plus 1. Multiplicity 2 means it is squared. And then we have x minus 3. Multiplicity 1. Do I have to put it to the 1? No. And -2, so x plus 2 squared. And we have a constant of -12, so that's at 0 and -12, because constant is a fancy word of saying y-intercept. Zero and -12. So we're going to get -12 equals A, 0 plus 1 squared. 0 minus 3, 0 plus 2 squared. -12 equals A times 1 times -3 times 2 squared, which is 4. -12 equals -12A. This one would have been okay if I just forgot to do my A, but we don't want to bank on it being okay. A equals 1. So we're going to get y equals your questions are not all of those because you've done some of them already. So on page 147, can you turn to 147 for a second, please? So look at number 3, please, on page 147, number 3. Number 3 is a graph. So instead of me giving you words, I gave you a graph to come up with the equation. So what are my x-intercepts on 3a? X equals -3, multiplicity 1. X equals -2, multiplicity 1. X equals 1, multiplicity 1. Same thing as this, right? You just have to pull the x-intercepts off. And you also need a point in order to find A, correct? So on a diploma, they'll either bold a point. If they bold a point, you need to use it somewhere. That's why they're bolding it. Or you use the y-intercept. So most of the time I use the y-intercept. The only time I don't use the y-intercept is if it passes through like not clear. Like it's kind of like partway through something. Then I pick another point to solve for A. You never pick an x-intercept to solve for A. It's not going to work for you. It's going to get you zeros. It's going to be bad news. Okay? Now, if I look at C, my writing, instead of having a graph, if I wrote it out like I did here for A and B, C would say an x-intercept at -4 multiplicity what? It's tangent. It goes to -4, bounces, and hits it back down. How many zeros are there? 2, multiplicity 2, right? And then x equals 1, multiplicity 1, x equals 3, multiplicity 1. Okay, what do people forget when they do this? They don't forget a lot when it's written. They forget to square and cube when it's a graph. And if it does that little S shape through it, it's 3, because they'll always ask for least possible degree. Because if they don't ask for least possible degree, you could say 3 or 5 or 7. There'd be so many answers, right? Pardon? It would just be longer, but they'll usually ask for least possible degree. So it'd be a multiplicity of 2. Yeah. So that's just this in graph form. Same thing, right? You just have to come up with the words off of here. And you need to use a y-intercept or another point to solve for A. Always, always, always. Make sense? So number 3 is one of your questions. Number 3 and number 4. And number 11 and 14. 3, 4, 11, and 14. I just kept going there. 3, 4, 11, and 14. So if I were you, I would just get working through my scheduled help here.